Hey guys, how we doing? I'm back. It's Mr. Chavla. I'm just going over the not June, August 2016 Common Core Algebra 2 exam. So in the previous two videos, I went over the first 12 multiple choice questions. So in this one, I'm gonna go over the key for part one. Let's say we go through numbers. So I went up to 12. Let's say 13 through I think 13 through 19 should be enough. Uh, and then I'll save the rest of the multiple choice for the last video. All right. If we have more time, I'll do more because I'm trying not to make these videos too long. So August 2016 Common Core Algebra 2 exam. So number 13. Okay, an equation to represent the value of a car after t months of ownership is V of t is equal to 32,000 times 0.81 to the t over 12. Which statement is not correct? Okay, so we just have to look at this carefully, guys. We have I'm going to do, first of all, t is the number of months, all right? I'd prefer to use an m. Um, so here's what I'm going to do. I'm going to rewrite this down here. V of t in function notation is equal to 32,000 times 0.81 to the t over 12. What this over 12 means is that it's loses, if you want to find out what the percent decay is, this is equal to 81%, right? To find out how much the percent decay is, because if 81% is what's left, 100% minus 81% is 19%. So this is the decay or decrease in the car's value. But if it was 0.81 to the t, that would mean 19% per month, right? 19% decrease per month because t is months, right? But it's to the t over 12. Whatever's in the denominator, that means it's a 19% decrease every 12 months, which is the same as a year, right? So this 0.81 is actually your yearly decay factor, which is just what we multiply by to decrease. So choice one, which one's incorrect? Choice one, the car lost approximately 90% of its value each month. No, it lost 19% of its value every 12 months or every year. All right, so choice one is not correct. The choice two, the car, so we know our answer is choice one. Now let's just look at the other one. The car maintained approximately 98% of its value each month. So I could rewrite this function, guys, like this. This is the same as 1t over 12. So that's 32,000 times 0.81 to the 1 over 12 times t. Remember, when I multiply exponents, I don't even care about the initial amount of 32,000, all right? This is the same as 0.81 to the 1/12th, all raised to the t power, where, again, t is months, okay? Because usually we use t for years and m for months, so I don't like the fact that they use t. I would have just rewritten this as m. So let's find out what 0.8 to the 1/12th is, or the 12th root of 0.81. And it's about 0.98 if you round it to two decimal places, and that's 98%, right? So that is correct. It does retain 98% of its value each month, so that's true. So that tells me in choice one that the car should have lost about 2% of its value each year if it's left with 98, I'm sorry, about 2% per month if it loses, oh my god, let me try that again. Okay, if the car maintains 98% per month, that means that it loses about 2% per month and not 19, okay? Uh, Now let's look at the choice three. The value of the car when it was purchased was $32,000. Yeah, that's just the y-intercept. If you substitute 0 for t, v of 0 equals 32,000 times 0.81 to the 0 over 12. It's your y-intercept. 0 over 12 is just 0. 0.81 to the 0, I'll just put 32,000. I put too many zeros. 32,000 times 0.81 to the 0. 0.81 to the 0 is just 1, like anything to the 0, right? So that's 32,000 times 1, which is just 32,000. But we don't need to do that. You could have also put it in a table in your calculator. So that's our initial value of the car is 32,000. So that's true. The value of the car 1 year, remember t is months. That means so after 12 months. So v of 12, it was $25,920. Sure, all I need to do is substitute 12 for t, so v of 12 is equal to 32,000.81 to the 12 over 12. Guys, look at what happens here. As a side note, this is 1 year, is 12 months, right? We multiply by 0.81 every 12 months because that's how it becomes to the first power in a year, right? So 32,000, this is just 32,000 times 0.81. You didn't have to do all this. You could have just put it in the calculator like this. But this is how I'm showing you. You actually multiply by 0.81, not every month, but every year. So if I put this in, 32,000 times 0.81 is 25,920. That's how it lost 19% of its value in a year and retained 81% in a year. So choice 4 is also correct. We didn't have to go through all those, but I wanted you guys to understand how this works. If you know how to manipulate exponents and understand that whatever's in the denominator means that that's what that we multiply by this once every 12 months, right? And not every month, then you'll be good, okay? It was a little bit tricky, but we could get this. Okay, it looks like my head got cut off. We fixed that. Okay, now let's go to 14. Which equation represents an odd function? Not the eraser, the highlighter. Odd function, guys, means that, so there are three types of functions. In an even function, I'll use green for even. If I substitute a number and its opposite, it won't make a difference. That means that the f of negative x is the same as f of positive x. So something like, for example, if f of x equals x squared, right? F of 2 is 2 squared is 4, but f of negative 2 is also 4, because when I square negative 2, that also becomes positive 4. And so x squared, f of x equals x squared is an even function, right? Not all quadratic functions are even, but this parent one is. In an odd function, the opposite is true. In an odd function, which I'll use red, in an odd function, what happens is that if you change the input to the opposite sign, then whatever the output will be the opposite of whatever you get if the input was positive. So for example, in the equation, let's say that f of x is equal to x cubed, right? A basic power function, then f of 2 is equal to 2 cubed, which is 8. F of negative 2 is equal to negative 2 cubed, which if you multiply negative 2 by itself 3 times, it's actually negative 8. Changing the input to the opposite sign, change the output to the opposite sign. That's all it means by odd. If neither of those happen, then it's neither. Okay? So let's look at choice, let's look at the ones we could do by hand, which comes to mind is choice 3. And let's say that we'll call this, we'll just call this one f of x, right? We'll use a different letter for each one. So f of x equals x plus 1 cubed. Let's just use 1 and negative 1 and see what happens. So f of 1 is 1 plus 1 cubed. 1 plus 1 is 2. 2 cubed is 8. So f of 1 is 8. If it's even, we should get f of negative 1 is also 8. If it's even. If it's odd, we'll get f of negative 1 is negative 8. Let's see what happens. F of negative 1, so let's see what actually happens. F of negative 1 is going to be, and you could have used tables in your calculator too, but this one's easier without it, for me at least. Negative 1 plus 1 is 0. 0 to the third is 0. That is not equal to 8 or negative 8. So choice 3 is neither. Alright, so we want odd, so choice 3 is out. Choice 3 is out because it's neither even nor odd. Alright, I'm going to cross that out so that it doesn't look, so that I only circle the answer choice. I don't want to mark the choice itself. Let's look at choice 1. Well, let's look at the sinusoidal. That means sine or cosine last. Let's look at e to the 5x. Let's say I try when x is 1. E to the 5 times 1 is about 148.413, right? Let's see what happens if I change the sign. If I do e to the 5 times negative 1. They're obviously not the same, and they're not opposites either. So e to the 5x is also neither. So that's out, right? That's neither. So it's going to be between choice 1 and 2. So let's go to our graphing calculator now. Nah, I actually like it in here. Let's just stick with this. So I'm going to clear everything out. I want to make sure I'm in radian mode. And let's just say, let's take sine of pi over 2 and then negative pi over 2. Let's start with that. All right, because that's what we usually do. Sine of pi over 2 is 1. Sine of negative pi over 2 is negative 1. Just because it works for one set of pairs, input-output, doesn't mean that it works for all of them. But so far it seems to be an odd function, because changing the sign to the sign, not meaning sine function, but the sign in front of the pi over 2. One is positive pi over 2, the other one's negative. Change the sign of the output. Let's try for one more. Let's say we do sine of pi is 0. Sine of negative pi then should also be 0, whether it's even or odd. Sine of 3 pi over 2 is negative 1. Sine of negative 3 pi over 2 is positive 1. So changing the sign of the input changes the sign of the output to the opposite. So sine is an odd function, and that's all we got to do, guys. If you look at cosine, you'll see that cosine will be even, because if I do the same thing, instead of sine, I change everything to cosine here. Cosine of pi over 2 is 0. Well, cosine of negative pi over 2, whether it was even or odd, would also be 0. Cosine of pi is negative 1. Cosine of negative pi is also negative 1. So you see how cosine of pi and negative pi is the same? Cosine is even. And it'll be good for you to memorize that, guys. So we got cosine here. Let's try cosine of 2 pi is 1. Cosine of negative 2 pi is also 1. All right? So cosine is an even function. So that's not the one we're going to pick, all right? You could also use symmetry about the origin and the y-axis. Even functions are symmetric in the y-axis. Odd functions are symmetric in the origin. I'd look that up, right? And neither would be, it's not symmetric in either. I'd look that up if you need to, all right? But that's the way that I wanted to do it, was just by substitution. All right, you could have also used tables. Let's move on to number 15. What I'm going to do for number 15, guys, is I'm actually going to use a smartboard because I'm going to need a lot of space for this. And you could have used your calculator as well. But I'm really a big fan of like making sure you guys know how to do it by hand, because I think you guys could figure out by yourself how to do it in the calculator. So I'm going to just do this. So the completely factored form of, and I'm going to minimize me. And I guess this doesn't need to be that big. So completely factored means we factor till we cannot factor anymore. All right? Okay. So the completely factored form of the polynomial. So first thing we want to do is see if there's a GCF. All of these have a GCF of 2D. So it becomes 2D. That's too thick. And then in parentheses, I'm going to get, and I'll use a different color now, D cubed plus 3D square. And you'll see why I'm changing the color in a second. Minus 9 times D minus 27. All right, now I'm going to keep bringing down the 2D, but as I do, and you see that in all the choices 2D is there, but as I do, I'm going to put a big set of parentheses, or you could even use a bracket here. I'm going to use factor by grouping. So this set of terms, the GCF is D squared, and I get D plus 3. All right, and then in the other one, the GCF will be negative 9, but I also get D plus 3 in the parentheses. So I'll actually put D plus 3 in black here so that they match, and a thick black color. And I get D plus 3 here. So D plus 3 is our GCF here in the parentheses. All right. So now, the next thing we're going to do, guys, is we're going to keep working inside this big set of parentheses, all right? So the GCF is D plus 3. So all I'm going to do now is I'm going to bring down the 2D, and the D plus 3 will come right here because that's our GCF. Then I'm going to bring the D squared minus 9 down here. Now the next thing I'm going to do, I only need one set of parentheses now. D squared minus 9 factors into difference of squares, D minus 3 and D plus 3. And then I want to bring down this D plus 3. But if I put it together, that becomes 2d times d minus 3 times d plus 3 square, or we could write it as 2d, we could put the d plus 3 square by the commutative property and then d minus 3 last. So that is choice 3, where we got 2d, d plus 3 square, and d minus 3. All right, choice 3. Okay, the completely factored form. I'm trying to make it like so it fits on the screen. Okay. We could have used the calculator to confirm by going to tables, and if we change the d to x and then it gets the same x values. Let me actually show you guys. I keep talking about it but not doing it. So let's just do that and I'll show you guys. The only thing is, like, just because it gives you the same one doesn't mean that it's completely factored. So it's equivalent, but it has to be completely factored, right? So what we'll do is enter the original one, but I'll use x instead of d because I don't think that it'll let me use d. All right, and then if I enter choice 2, and I'm a fan of using this, guys, instead just to check, because the problem is that it said it has to be completely factored. So you could get a correctly factored form that's not completely factored. In the case of choice 1, because you see how in one step we got 2d d squared minus 9 and d plus 3, and this has 2d d squared minus 9 and d plus 3. 2d d squared minus 9 d plus 3 is over here. 2d d squared minus 9 and d plus 3. I'm just making sure they're the same because sometimes, like, they trick and I miss stuff. But anyway, if we put that, we would have gotten the same values in the tables too, but it would have been incorrect because it's not completely factored. So what I'm going to do is now enter table. All you got to do is check for a few positive numbers, a few negative numbers, and then make sure we just keep getting the same values for all input values. And the zeros could also help you get the factors. So you see -5, -4, they give us the same output. -3, -2, -1, 0. If that's the case, the only way that's possible is if these two expressions are equivalent. So it helps to check that they're equivalent. If they said what's equivalent, you could have just used the calculator. And the same goes when dividing polynomials. That was one of the earlier questions. But again, it's like completely factored. So even though this one, choice 1 would have been fine. What happened? Where did it go? Did I not pick it? Oh, I was in the smartboard. I got so confused. Remember, because it said completely factored. So this one, while it is equivalent, it's not completely factored. All right, and the answer is choice 3. All right, so I'm going to circle that over here. Pause the video if you need to. I'm going to circle choice 3, and let's move on to question 16. Which diagram shows an angle of 1 radian, an angle of rotation of 1 radian on the unit circle? So unit circle has a radius of 1 and a center at 0, 0. So this will be the point 1, 0, right? If you remember, guys, the rotation went like this. I'm not going to draw the whole circle. If we go all the way up to here and we stop on the unit circle, this is pi over 2 radians, or 90 degrees. All right? If we go, I'll use a different color, like this. I'll use blue. If we go all the way here, that's a straight line 180 degree rotation, right? This is 90 degrees. That's pi radians, or 180 degrees. Okay? If I go all the way up to here, that's going to be 270 degrees because it's like 3 right angles. And that's also equal to 3 pi over 2 radians. Actually, I should be writing that right here. So 3 pi over 2, that's 3 pi over 2. That's a mess. Let me try that again. Or 270 degrees. And then choice 4 here is 2 pi radians when you made a full circle, or 360 degrees. Remember 360 degrees in a circle? So 1 radian, if you look in the reference table, they give it to you, but if you use the fact that 180 degrees is pi radians, you could use that to quickly find the measure of 1 radian in degrees. That's one way to do it, but let's look here. 1 degree is pi over 180 radians, and 1 radian is 180 over pi degrees. So we could just use that to real quickly, because they're already saying it's 1 radian, so it's equal to 180 over pi degrees. So let's just find out what 180 over pi is, right? So 1 radian, that's equal to 180 over pi degrees. And let's just find out what 180 over pi is. (180) divided by pi is about 57.29, about 57.3. Okay, that's an acute angle. 57.3 degrees. Remember, this is 90 degrees, goes all the way past the first quadrant. Only this one would be 1 radian, all right? This is pi radians, because remember that was this one right here. All right, that's 180 degrees. The choice 4 is out because that was 2 pi radians, right? And this is pi over 2 radians, which is 90 degrees. So that's out. And this one was 180 degrees. All right, so that's out. So our answer is choice 1. That was one of the ways to do it, guys, just to convert it to degrees. There were other ways as well. You could, but I won't do that right now, okay? We'll move on to number 17. Okay, the focal length f of a camera's lens is related to the distance of the object from the lens J and the distance of the image area in the camera by the formula below. Basically, we just need to use this formula here. We didn't need all this extra information in this question, and the only reason I know that is because I've seen it a few million times, and I'm only slightly exaggerating. When this equation is solved for J in terms of f and w, J equals, so basically they're just saying you want J by itself on one side of the equal sign. So the logical thing to do, guys, is to subtract 1 over w on both sides first, and we get 1 over J equals 1 over w minus 1 over f. Now remember, usually we use numbers, but we need to get the variables to be the same, and I'll just put it in alphabetical order. So I got to multiply by f here, because we need the denominators to be the same. W here, and w, and I'll put a w here, right? Put the w here. So this becomes f times 1 is f over fw minus w times 1 is w. That's equal to 1 over j, right? Now you could either cross multiply, or since we want to get j by itself, let's just flip the fraction. If I flip this, this becomes j over 1. Flip this, it becomes fw over f minus w. And I could have I could have cross multiplied and it would have been the same thing. So we want, but this j divided by 1 is just j, so we get j equals fw over f minus w. So this is clearly not correct. Here we have fw over f minus w. I made a mistake. I just got this backwards. It was supposed to be 1 over f minus 1 over w. So, but the idea is the same. So I multiply by w and w, f, and I'll just put the f here, and it actually becomes w minus f. I didn't mean to cross out that equal sign, guys. That was just a mistake. Okay. So that becomes fw, and then when we flip the fraction, take the reciprocal, it's fw over w minus f. So not f minus w, because this says fw over f minus w, and this is obviously wrong. We want fw, so j equals fw over w minus f. So here we got it, fw over w minus f. Fw over w minus f, choice 3. Okay, moving on to number 18. The sequence a1 equals 6. I'll use all the space here. So a1 equals 6. That means the first term is 6. And to get the next term, you multiply the previous term by 3. That's a geometric sequence. So it just goes 6 is a1, a2 is 18, a3 is 18 times 3 is 54. So if you look in the reference table, and we did it earlier when we were doing a geometric series, they're saying what's the explicit formula? We get an is equal to a1 times r to the n minus 1 So that will become an is equal to, right, our r is equal to 3, the common ratio. Um, so a1 is 6 times 3 to the n minus 1. Let's see if they gave that as an option. This one says 6 times 3 to the n, so that's out. 6 times 3 to the n plus 1. So it has to be one of these two. So guys, what I could do is if you started at a0, that's the fastest way to do this, which we don't actually have one. What would we have to multiply by 3 to get 6? 2. So if I start at a0 instead, which then you don't need to do n minus 1, so it becomes an equals 2 times 3 to the n, which is choice 3. And we could confirm in the calculator, guys, by using the table feature. So let's clear this out. Actually, so I'll write, in this one, I'll write 2 times 3 to the x. And the original one that I wrote was 6 times 2 to 6 times 3 to the x minus 1. All right, and we're not dealing with negatives. And even though we don't have a 0, right, it starts at 2. You see how both of them start at 2 with 0, but the first term is 6. And then each one is times 3 from the previous one, but they gave us the same values. And you could have used the calculator to solve this one too. But let's move along. Question 19. Which equation represents the set of points? And 18 was about knowing how to convert between recursive and explicit formula for geometric sequence. Also important to know how to do that for a arithmetic sequence, which is common difference. But anyway, which equation represents the set of points equidistant from line L, which has equation y equals 1, it's a horizontal line, and point R, this is 2, 1, 2, negative 3. So that's 2, negative 3, shown in the graph below. Guys, remember this, the set of all points equidistant from a line and a point, the directrix, this is the directrix, is a line. The point is called the focus. So it's focus directrix equation of parabola. So all the points have to be the same distance. So first thing, our parabola will have a vertex halfway between focus directrix. So 1, 2, 3, 4 is the distance from focus to directrix. So then 2 is the distance from focus to vertex, and 2, negative 1 is our vertex. So if you remember vertex form, y equals a x minus h squared plus k. And by the way, our a value should be negative because it has to open down because the parabola is not allowed to cross through the directrix or touch the directrix. So a will be less than 0. And I substitute where hk is the vertex. So h is 2, k is negative 1. So it becomes a x minus 2 squared minus 1. Let's see if we could eliminate choices first. So these have x plus 2, and this has a plus 1 here. So x, we have a negative leading coefficient, which we should. X minus 2 squared minus 1. By elimination, we have choice 4. If you wanted to take it a step further and see how we get this equation, we replace a with 1 over 4p, where p is the distance from the focus to the directrix. And since it's opening down, it's negative 1 over 4p. And remember, focus, not focus to directrix. Focus to vertex, or vertex to focus, is 2 units, which is the same as vertex to directrix. So p equals 2. So if we substitute, we get y equals negative 1 over 4 times 2, because p equals 2, times this whole equation. And since 4 times 2 is 8, it becomes y equals negative 1 over 8. That's a bad 8. Let me fix that. I don't know why sometimes the mouse cursor shows like this and other times it's just a dot. I wish that this would show all the time so you could see what I'm doing. But this is the same equation, negative 1/8 x minus 2 squared minus 1. And here we got it, negative 1/8 x minus 2 squared minus 1, choice 4. All right, moving on, question, and it's focus directrix equation of parabola. Okay, Mr. Farrison gave his class the 3 mathematical rules shown below to either prove or disprove which rules can be proved for all real numbers. First thing, guys, if you know the shortcut to square a binomial, you square the first term, then you multiply the two middle terms, keeping the same sign as what we had here, then you double the product, and then you square the last term, and we get m squared plus 2mp plus p squared, which is what we got right here too. So option 1 is correct. So anything without option 1 is out. So that means we cross out choice 3. Now we're going to check option 2. If we continue along the lines with, we could use something called Pascal's triangle. But if we continue along the lines of what we use in option 1, I could rewrite x plus y cubed as x plus y squared times just x plus y. And x plus y squared becomes x squared plus 2xy plus y squared times x plus y. And then I'm just going to distribute. First I'll distribute the x squared over x plus y, and I'll get x cubed plus x squared y. Then I'm going to distribute the 2xy to get plus 2x squared y plus 2xy squared. And then finally distribute the y squared to get plus xy squared plus y cubed. And then all I have to do is combine my like terms. The first term is x cubed. That's not going to change. This is 1x squared y plus 2x squared y is 3x squared y. Combine these two and put a 1 here. It's 3xy squared. And then the last term is y cubed. But this is clearly not correct. So option 2 is out. So this choice is out. Now all we have to do is see if option 3 works. All right. And I would highly encourage you to look up Pascal's triangle. That'll help you to be able to raise a binomial to any power much more quickly. Not just the third power, but also fourth, fifth, and higher. And it's not that difficult, okay? But let's look at choice at option 3. So the first one, a squared plus b squared. When I square it, guys, if I square the first term, a squared squared is a to the fourth. When I multiply a squared times b squared, it's a squared times b squared. And then I double the product, just the same rule as when I did with x plus m plus p. And then I take b squared and square to get b to the fourth. Now let's see if I do that with this, if it gets the same thing. So I need to get this with the other one as well. And let's see if it ends up being the same thing. And I'll use blue for that. So a squared minus b squared square plus 2ab square. Well, this just becomes 4a squared b squared. Okay, and it's added. If I square, and I'll use red here, this becomes a to the fourth, using the same logic as, right, where you square the a square. Then you take the product, and it's a squared b squared, right? Negative a squared b squared, and then you double it to get negative 2a squared b squared. And you could distribute, but it's a lot easier this way, plus b to the fourth. Now, these two terms are like terms. 4 minus 2 is 2, so it becomes a to the fourth plus 2a squared b squared plus b to the fourth. Let's see if it ends up being the same. We got a to the fourth here, and we got that here. Plus 2a squared b squared, check. Plus 2a squared b squared plus b to the fourth, check. So option 3 also checks out, but not option 2. So it's choice 4 for options 1 and 3. All right? It was just knowing how to distribute binomials, all right? How to multiply binomials. Okay, and if you know the rule, it's easier than having to multiply it one by one. Let's see, what number did I say I go up to? I'm going to go back to the beginning and see what number I wrote. I said up to 19, all right? I went one extra than that, up to number 20, okay? So I'm going to save the last 4 problems for the final video, okay? The last 4 multiple choice problems. All right, Mr. Chavla back. Sorry I didn't show my face. I don't know if it matters to you, but again, I wish you best of luck. Study. If you have any questions, comments, as always, you guys know the drill by now, right? Let me know. I'm here for you. I wish you the very best, okay? And if you enjoyed the video and if you found it useful, please hit like, subscribe, tell your friends. Appreciate it very much, all right? Bye. Take care, guys. Best of luck.